Hello, everyone. We are back again. I hope each and every one of you is doing well. We are back to our math journey. And then this journey, we want to make math easy and comfortable as possible. If you haven't yet subscribed to our channel, Tutoring Made Easy, please do us a favor to subscribe to our channel. Yes, do us a favor to subscribe to our channel, like this video, and share it to as many people as possible. All right, we're going to continue our topic on sets, but today we're going to look at a concept known as Venn diagram. I wanted to share with us on the concept of De Morgan's laws, but I felt it would be better to start with the Venn diagram first, and then we will continue another time with De Morgan's laws. It's going to be fun. It's going to be interesting. So roll up your sleeves and let's dive into it. Let's dive into it. Now, Venn diagram was propounded by by John Venn in the year 1880. It was propounded by, so we'll say that it was propounded. It was propounded by John Venn in 1880. 1880. Now, when we talk about Venn diagram, it's a depiction. It's like a diagram. Um, it's a diagram that depicts, like, let's say, sets, right? The diagrammatic depiction of sets. There's a diagrammatic, diagrammatic depiction of a collection of sets. Usually it's of the form this way. You draw like a rectangle or maybe a square depending on what you're looking at. You want to use a different color. You draw like a rectangle or a square. Maybe you draw a rectangle or a square, and in this square you are able to have your you know your sets in there. So that's a diagram depiction of what a Venn diagram or how a Venn diagram looks like. All right, it was propounded by John Venn in 1880, and then it can be described or usually of the form like a rectangle with a collection of sets inside of it. Inside of it. Today we are going to look at two set Venn diagram. Two set diagram. This Venn diagrams come in two forms. We have two set diagrams, and we also have three set diagrams like this. So you can have something like this, another set like that, okay, and then you have three sets together. So this is a three set diagram, diagram, Venn diagram, and it's a two set. It's a two set Venn diagram. All right. Now there are certain rules or certain things we need to know when we're talking about Venn diagram, and we're going to go through them before we we actually do real problems and stuff like that. Before we do real problems and stuff like that. All right. So we are going to take a look at some of these concepts. So we are going to start off with the two set Venn diagram. The two set Venn diagram. Two sets Venn diagram. I'm going to start with this one like that. Okay. So let's try and draw something. So we're drawing this like that. It's just two sets diagram. And inside this diagram, we have these two sets together in there. Now, this set, we can call this set A, the one on our left, set A. And then we can call the one on our right set B, like that. Now we said that for every set, for every Venn diagram, let me put it that way, we have what we call the universal set. This one, you need to write it this way over here on top to the other side, or you can write this symbol there. That shows that the whole diagram you are having is the universal set, and then you have the sets inside them. You have the sets inside them. We are currently going through some of the rules, so don't be too worried about questions. We'll find time and do practical problems on Venn diagram. But for now, I want to lay down the rules or the things that we need to know about Venn diagram. Now we're going to have members which are outside these two things. All right, we're going to have members which are outside these two circles, which is set A and set B. They are outside. Now we're also going to have we're going to have we're going to have this side only this side. You can see because of this white thing here, we are ending it there. And then we're also going to have on that side, we're going to have this green color to here, like this. Okay. And in the middle, we can have another color like this in the middle, like that. Now, each of these colors that we've drawn in the Venn diagram means something. It means something. Number one, we can tell that since we have a yellow lines, these are yellow lines. This yellow lines helps us know that um, A union B, when you join A union B, when we join A union B together, the two white circles together, and we find a complement, that is the region there. This region is A union B. And because we shaded it in yellow, it means that something is there, something exists there. And if something exists there, it means that that thing is A union B. A union B cannot be zero, right? A union B cannot be zero. It can't be zero. It can't be zero because there's something that is there. A union B has something. It cannot be zero. It cannot be zero. Now, here, the thing here, the blue color stands for A, the intersection. Remember, the intersection of A and B. Why? Because they meet there. That's where they meet. That's where you can find members that are in A. You can tell. Members that are in A are also in B. You can see the rings, the two white rings. One of it is for A and the other is for B. So that's where both of them meet. Now, if we look at the red color here, it means that you have A. That area is A, right? It is in A, sorry. Sorry about that. This area, you can tell, it's in A, right? It's in the ring A. And the intersection. And not in B, right? We don't have any red color in B. You can tell, right? So it is A and not B. Not B means B complement. A and not B, which means B complement. So keep that in mind. And then the blue color, the blue region is A together with what? B. It's A together with B. Now, what about the green side? The green side here. The green side here. The green side here is B, right? Is the region of B, but not A. So it is not A. There's no A complement, not A. This is not A, right? Not A. It is not in A, but it's in a universal set. Here, it's not in A, but it's in a universal set, right? Everything that you're seeing in that box is a universal set. So we remember we talked about complement. That complements, they are in the universal set, but they are not part of that set in question. So this region is not A, right? It is not A. But it is B and B. It is B because it's in B. Now, because we have been able to establish that, let's look at what gives us our A. Now, set A is the whole of this region, right? Set A is this whole region. This is set A. So we can say set A is what? A and not B, right? Added to A intersection B. And don't forget the A intersection B is only one. It's only one. Now we can also say that set B, we can also say that set B, right? Set B, it is what? It is this A intersection B added to not A and B. This one here. These two. You set B. But can you see that there's a double? The A intersection B has become double instead of one. We can see that it is here and it's also there. It is here as well, right? But meanwhile, it's supposed to be only one, right? Now, we are going to look at something. Now, we are going to look at the joining of these two sets. If we look at A, right? If we look at A union B, A union B is everything in A and everything in B, right? And if that's the case, if that's the case, if that's the case, we're gonna have it's basically A adding A to B, right? Adding A to B. What is in A? The ring A, the whole of ring A plus the whole of ring B. That is what A union B means, joining the two sets together. And if it is A and B, if it is this and this, we know that A is what? We know that this is A. Let me take it again. We know that this A is what is right here, which is A and not B plus A and B. And we also know that this B, the B right here, is this one here. So that's going to be plus, right? Because this is for A plus B, right? And B is A intersection B plus not A and B. And we can see that there's a double. This one is double. So we need to find a way to take it out, right? However, therefore, we're going to have A union B, because we have to take this one out, right? It is going to be basically A union B is going to be A plus B, taking out the double, which is A and B. That is A union B. So A union B is adding the two, but you have to take out one of the A and B, because when we add A and B together, we are having two of this A and B. We need to take one out so that we can be able to arrive at that. So I hope you can see the parts. We're saying that the yellow side, the yellow side is A union B complement. A union B complement. When you join the two sets A and B together, and they are outside itself, they are in a universal set. That gives us A union B complement, not A union B, not just the joining of the sets, but after joining the set, those that are in the universal set, but they are not in the joining of those two sets, is called A union B complement. Now the one in red is A, they are in A and not in B, A and not B. And then the one in the middle is the intersection point where they both meet. So it is A intersection B. Then the one in green is not in A and in B. So it is in B, but it's not in A. And then we looked at how we can bring them together. We said set A will be that, and this set B. So if we bring them together, we are getting a union. If we bring them together, A intersection B, we are getting a union. But what it will mean is that we're going to get double. This is double. So we need to take one out. So A union B is joining A plus B, but you take one out of it. Therefore, let me write that concept here. We know that A union B as a concept is A as a set, adding it to B as a set, but taking out A intersection B, because A intersection B is double. Here, there's A intersection B here. And there's also another A intersection B in there. We need to take one out. So that's the concept right there. I think we should end here. And then when we come the next time, we will look at maybe 3 Venn diagram and then there are possible areas. But I think something is coming to my mind. Before we go, there is something called, you can see a problem and it can ask you, can ask you this question. You can be asked to look for this question. They can tell you what is exactly one. We say exactly one. We can see that this side here, the red color, exactly one is the red plus the what? The green. Let me use the colors. Is the red plus the green. That is exactly one. Is the red plus the green. They give you exactly one because this region, the red region, is only one thing happening there, and the green region is only one thing happening. When you bring them together, it is exactly one. But when you talk about exactly two, then you're looking at the A intersection B. You're looking at the blue. You're looking at the blue is the A intersection B. It gives you exactly two. All right. So we'll end here, and then we'll continue when we meet another time. But before we do, I'd like you to do us a favor by subscribing to our channel, Tutoring Made Easy, and liking this video and sharing to as many people as possible. We'll come to you another time. Take care and bye.